In this video, we're going to look at one more example of putting a 3x3 system into triangle form. A really important thing to notice about the process of putting a 3x3 system into triangle form is you know what your goal is, but you don't necessarily follow the same exact steps for every single system. So putting a system into triangle form is all about taking a holistic look at the system, seeing where it's different from triangle form and what you need to do to change it, and then going through the steps to change it into triangle form. That in mind, let us once again paste in kind of our guiding principles for what we are allowed to do in putting a system into triangle form. And let's take a look at this system. So we'll number the equations like we always do. The first equation is kind of awkward. It doesn't have it doesn't have a y term. It has an x term and it has a z term, but in terms of what we want that triangle form to be, if you guys remember from the previous video, we want the first equation to have all three variables in it, the second equation to have only y and z, and the third equation to have only z. So the fact that the first equation has no y term is neither here nor there. So what I'm going to do is I'm going to ignore the first equation for just a minute. I'll come back to it and I'll figure out what to do with it later. What I am noticing that seems to be extremely handy, however, is that the second equation and the third equation both have 2x as their x term, which means that if I add them together, or rather, if I multiply one of them by -1 and then add them together, I'm going to eliminate the x term. And that's a great way to get that second equation taken care of where I have only y and z. So that's going to be what I do first. So I'm going to take my second equation and I'm going to multiply it by -1. And then I'm going to add the third equation to it. So that's going to get me -2x plus y plus 6z is equal to -4. And 2x plus 3y minus 2z is equal to 8. And when I add them together, that leaves me with 4y plus 4z is equal to 4. And by total happenstance, this is totally lucky in this case. I can go ahead and divide both sides of this equation by 4 to make this equation even cleaner, even simpler. Y plus z equals 1. So let's take stock of where we are with our system now. So I have x minus 4z equals 1. That's my first equation. I didn't change it. My second equation I changed into y plus z equals 1. And then my third equation I have not changed. It's still 2x plus 3y minus 2z is equal to 8. Okay. So what do I think here? So I now want to get rid of, well, I think one way to do this, and you might find a different way. And so I encourage you to puzzle over it if you like. But I think what I'm going to do is I'm going to use the first equation to eliminate x out of the third equation. And I'm going to use the second equation to eliminate y out of the third equation. Okay, so here we go. So I'm going to take the first equation times -2, and I'm going to add that to the third equation. Okay, so that gets me -2x plus 8z is equal to 1, and then 2x plus 3y minus 2z is equal to 8. Okay, and I made a little mistake there. When I was multiplying the first equation by -2, I should have multiplied across the board, so that should have been -2. So now I'm going to add these, and by design, the x's reduce off. Now, you can think of this first equation as having 0y as the y term, and so we have the x's reduce off. So we're left with 3y plus 6z is equal to 6. Okay, so that's our new third equation. And again, we're pretty lucky. This doesn't always happen, but we can divide everything through by 3 to make it simpler. So we have y plus 2z is equal to 2. So this is my new third equation. Now remember, we said that our plan was that we were then going to use the second equation to eliminate y. So I'm going to go ahead and go straight into that. I'm going to take my second equation, multiply it by -1, and then add that to my new third equation. So my first equation times -1 is -y minus z is equal to -1. And then here I have y plus 2z is equal to 2. And when I add these, I have the y's cancel out, and I'm just left with z is equal to 1. So, yes, my first equation is awkward. It's missing a y term. But even though the first equation is missing a y term, it has an x term and a z term, and I can put a placeholder y term in for looks. My second equation is where I want it to be. It's got a y term and a z term, but no x term. And now I've got my third equation where I want it to be. It has a z term, but no x or y terms. So I'm going to go ahead and say this is good enough. So I'm going to say that my triangle form is x plus 0y minus 4z is equal to 1. Y plus z is equal to 1. And z is equal to 1. So is this kind of the standard triangle form that we've come to be used to? I don't know, maybe not, but it's definitely good enough. So I'm going to go ahead and highlight the triangle in orange so that you see that it is in triangle form, even if the first equation's y term is 0y. So that will happen sometimes. Okay. So what I'm going to do next is much the same that we did in the last system. I'm going to take my original system, and I'm going to copy it over to a fresh page. Okay, so original system. And then the triangle form and I'm going to bring that over from here. Okay, so now I'm going to use back substitution to find the solution. And once I do, I'm going to go ahead and check it. So I already know that z is equal to 1. So I'm going to go ahead and highlight that here. Z is equal to 1. This is good. So now I'm going to take that and I'm going to plug it into the second equation to find y. So that tells me that y plus 1 is equal to 1. So subtract 1 from both sides. So we get that y is equal to 0. Okay. And then finally, now that I have y and z, I can go to my first equation to get x. So I have x, I don't know x yet, plus 0y, y is 0 anyway, so that's just 0, minus 4 times z, which is 1, is equal to 1. So I have x minus 4 is equal to 1. So we add 4 to both sides, and we have that x is equal to 5. So it looks like the solution to my system is written as an ordered triple 5, 0, 1. And just to be sure, let's go ahead and check this. So first equation, x minus 4z. So I have 5 minus 4 times z. That should be equal to 1, and it is. So that's good. Second equation, 2x minus y. I mean, y is just 0. Minus 6z. That should be equal to 4, and it is. 2 times 5 is 10, minus 6 is 4. Last one, this is looking promising so far. 2 times 5 plus 3 times 0, that's just going to be 0. Minus 2 times 1, that should be 8, and it is. 2 times 5 is 10, minus 2 times 1 is 8. So it checks out. So there is another example of a system that we solved by putting it into triangle form, and that we finished by writing the solution as an ordered triple and then checking it. So again, solving a 3x3 system by putting it into triangle form is going to be different for each system. It's really important to make a plan and stick to it, unless you discover the plan's not working, in which case try again. Start from scratch, do a new plan. Some systems are going to be messier to put into triangle form than others, but by and large, the systems we encounter, it shouldn't be too bad. Happy solving. That's all we have on putting 3x3 systems into triangle form. Stay tuned for the next video out of the systems.